In this lab, we're going to explore measuring mass and then converting mass to moles. You can see the purpose here is to look at the masses of several different samples of chemical elements and then use the data to do some conversions. And so eventually we'll be able to count atoms. You can read through the background here. It talks about Avogadro's number, which we talked about in class. And then there's a pre-lab question, and then here's the procedure. We're going to start the virtual chem lab. So we're going to open this up. And then instead of looking at the experiment list, we're just going to go straight into calorimetry here. So the calorimetry lab it'll take a second to load. And so here's the calorimetry lab. And it says, click on the stockroom, click the metals sample cabinet. Okay, so we're going to go to the stockroom. The stockroom is right back here. We're going to click on that. And there's our metals cabinet. It then says, open the top drawer by clicking on it. When you open the drawer, a Petri dish will show up on the counter. Place the sample of gold in the sample dish by double clicking on it, and then zoom out with a green arrow and place the Petri dish on the stockroom counter by double clicking on it and return to lab. So we're going to open the top. We see gold. We can move gold out. That's the Petri dish. Close that out. Okay. We zoom out. We can put the gold there. Then we're going to return to lab. There's the gold, okay, on the corner of the stockroom. Drag the Petri dish to the spotlight near the balance. So when you pick this up, there'll be a couple different spotlight areas that it allows you to move it, and that's the one by the balance. Okay. Now, click on the balance area to zoom in, drag a piece of weigh paper to the balance pan, tear the balance, and drag the gold sample on the balance pan and record the mass in table 1. So we're going to zoom in here. This is the balance. Okay. We're going to take a piece of weigh paper. We're going to put it there. We're going to hit tear. Tear is just a function that's going to zero out the balance. We want to get the mass of gold. We don't want to get the mass of the weigh paper. And so that's why we're hitting tear there. And so you'll move the gold there, and then you can get the weight. So again, everybody's going to have a different weight. I do not expect your weight to be 51.3459, right? You should get a different weight than this. You're going to see some variation like you would see in the lab. Again, this happens because people are walking across the floor or there's a breeze. You'll notice that this balance is a little more specific than the balance that we used earlier because it's got 4 decimal places, okay? And so, okay, so we record the mass in table 1. Then we click on the disposal bucket and clear the lab. You're going to repeat this for lead, uranium, and sodium, okay? They have some kind of examples here for you. You need to write your own sodium data here. So let's see, gold, we'll put your gold here, we'll put your lead here, uranium, put your sodium data here, okay? So you've got some example sodium data, but you're gonna put yours here. You need to calculate the moles of gold and enter it into table 1. You need to show the calculation with the proper units and canceling out. If this is not enough room for you, then you need to attach a scratch sheet of paper to this or another piece of paper where I can follow this. And if you do that, you just need to say, see attached work. Same thing, you need to calculate the atoms of gold contained in the sample and enter it into table 1. You need to show your calculation here. You need to show your work. So make sure you show your work here and show your work here. If you do not show work, you will get no credit. You need to repeat the calculations from question 1 and 2 for all the other metals. So I want to see the work for the moles and the atoms for each one of these metals. So you should have the work, not just the answer, but the work for 8 boxes right through here. All right. Now, this is procedure 2. We're going to click on the stockroom again. So I'm going to zoom out. I'm going to clear it. I'm going to click on the stockroom, and then it says double click on the sodium chloride on the salt shelf. And the right and left arrows here, so there's right now we just have arrows moving to the right, but if you move to the right, you'll have an arrow moving to the left. Just allow you to see additional bottles. And then we're going to return to the lab. So I'm looking for sodium chloride. It's right there. I'm going to put it here. I'm going to return to the lab. Now I'm going to drag it over here because we're going to weigh it again. And so it says, move the sample bottle to the spotlight near the balance area. Click the balance area to zoom in and open the bottle by clicking on the lid. Drag a piece of weigh paper to the balance pan and tear the balance. Pick up the scoop and scoop out some sample. As you drag your cursor and the scoop down the face of the bottle, it picks up more. Select the largest sample possible and drag the scoop to the weigh paper until it snaps in place, which will place the sample on the paper. Record the mass in table 2. Okay, so again, we're going to zoom in to the balance. We're going to remove the lid. We're going to put a piece of weigh paper here. We're going to hit tear because we don't want to weigh the weigh paper. We're going to pick up the scoop, and you're supposed to be able to kind of move it across like that and then deposit it there. And so I've got 0.2065. Now, if you would like more, right, you can add more to that. But it looks like it's not going to let me add more. So it looks like my sample is 0.2065. So you record that. You can zoom out and then get rid of that. So you record that here. There's the molar, you're going to calculate the molar mass of sodium chloride, and then you are going to calculate the moles of the compound, the moles of each element, okay? And so there's a mole of sodium for every 1 mole of sodium chloride, and then the atoms of each element, okay, using Avogadro's number. So with these questions, it's just saying calculate the moles contained in the sample and record your results, calculate the moles, calculate the atoms, and then repeat steps 5 through 7 for all the other compounds. You need to be showing your work. My good guess is you're going to have to attach a separate piece of paper to show your work to do this. So just kind of be aware that you're going to need to do that. You also get to do a compound of your choice, and so you can fill in whichever compound that you're interested in from the compounds in the stockroom. So you can look through and figure out which one you want to do.